Welcome to the video lessons of class 12th physics. We will learn about the various things, about the various topics from the second chapter of the electrostatics. And today we will learn about the electrostatic potential. We have learned in the previous chapter about the charge and its behavior. Behavior, that is towards the other charges and towards any configuration of the charges. Basically, we know that the charge at rest creates the electric field around it, and if any other charge is kept in this field and it is left free to move, then what will happen? It will move, it will go away from this charge. Now conversely, if we want to bring this charge towards this charge, then we will have to, that is the external agency, will have to do work, right? And if it is left to move freely, then it will move away from this charge. In that case also work is done, but who will do the work? The electric field will do the work. In any case, the work is to be done. Whether we want to bring this charge towards the source charge or it is left to free move, right? And in this, we want to bring this charge opposite to the electrostatic field due to this charge, right? This charge is positive. This is also taken by convention positive, right? So this will move away, that is in the direction of the electric field. Okay. Now this charge is to be moved opposite to the field, that is this way. And work is to be done by the external agency, by the external force. And definitely this force is to be equal and opposite to the electrostatic force, right? Why is it so? Because we don't want to give any acceleration, we don't want to move this charge with any acceleration, right? It is to be moved only, without acceleration. So the work done by moving the external forces, this charge Q from R to P will be written as this: force into distance, right? Work done. And this will be the work done this way. Okay. This work done, what happens to the work done? Work done gets stored as the electrostatic potential energy. So we can write this work done, that is the difference in the potential energy between the points P and R. Now that we want to have this work done not for whole charge but for the unit charge. We want to make this work done independent of the charge which is to be moved, right? So we can have the work done in bringing a unit positive charge from R to P, that is against the field as this, and this is by definition as the potential difference between the points P and R, right? So Vp is the potential at P and Vr is the potential at capital R. Further, the work done in bringing a unit positive charge, now we want to take from infinity. Why from infinity? Because at infinity, what about the electric field of this source charge? This is the 0, right? So let us move the unit positive test charge from infinity to the point P. We can write this way, And if we are able to calculate, then we will be able to know the potential, mathematical format of the potential at point P in the field of the given charge. So let us do this. That is, let us find the potential at a point due to point charge. Here it is, source charge P per. So at P we have to find out the electric field, electric potential due to this charge. We want to bring this charge, unit charge, from infinite to this point P. Right? We will bring this, we will move this unit charge in infinitesimally small steps. So first of all, the very small amount of work done in moving unit positive charge from A to B, that is ds, against the field will be this. Angle between E and dx 180 degrees, so we will have this edx. And for the work done from infinite to P, we will have to integrate this dw. Right? So integrating this from infinity to point P, that is small r, we will have this. Putting the value of the E and integrating 1 upon x square dx, we will have minus 1 upon x. Apply the limit to have this upper limit minus lower limit. Right? The potential will come as 1 upon 4 pi epsilon naught capital Q, that is the source charge. Nowhere any charge you are moving. Instead of the 1 coulomb charge, unit charge, if you take Q, then this will not be in the expression because we are finding out the W upon Q. That is the work done to move the unit charge. So from the expression it will disappear. So it is to depend on this only. Right? So this will give the mathematical expression for the potential at point P, which is distant r from the source charge. And hence we have V proportional to 1 upon r. Hence, if we plot the graph between V and 1 upon r, then a straight line. This side graph, definitely it is going to be Q positive more than 0, right? And for Q less than 0, the graph will be of the same nature but this in this quadrant, right? Also we have V into R, right? V is inversely proportional to R, right? Then the graph will be this way. When R closer, then V will be greater. And for the negative charge, that is Q less than 0, V versus R graph will be this way. After having learned few concepts, few definitions about the potential, and from all this mathematics and physics, we can tell whether potential is a scalar or vector, right? And what does the potential difference between the 2 points in the electric field of the charge or configuration of charges determine? What is the use of, what will happen? Right? If the potential difference is more, then what will happen to the charge placed in the electric field? If the potential is 0, then what will happen to the charge placed in the field? Right? So after this lesson, we will reach the next lesson, the next topic, and then later on I will take answers from you to these questions.